This presentation will discuss the application of relationships when modeling relational databases. You already know that there can be one-to-one, one-to-many, and many-to-many relationships when modeling a relational database. Many-to-many relationships can't be implemented in a relational database model. So we need to normalize our data, and the purpose of normalizing is to eliminate a many-to-many relationship and get to an ideal one-to-many or one-to-one relationship. As a general rule of thumb, though, a one-to-one relationship is fairly rare. However, in the simple solutions that we're building in the start of this unit, you may find that they regularly occur just because they're quite simple. As mentioned in the previous slide, the one-to-many relationship is the relational database norm. You can see in the picture below the relationship between the painter and his paintings. So you can see here the one painter has many paintings. This slide shows you how the data is referenced across the two tables to reduce the redundant data. So remember, redundant data means that it's duplicated data. There's only one row in the painter table for any given row in the painting table, but there may be many rows in the painting table for any given row in the painter table. This is a one-to-many relationship. Students in a typical college or university will discover that each course can generate many classes, but that each class may refer to only one course. The entity relationship diagram below illustrates the one-to-many relationship between courses and classes. Each course can have many classes, but each class references only one course. So in the table you can see that there is only one row in the course table for any given row in the classes table. In a one-to-one relationship, one entity can be related to only one other entity, and vice versa. For example, only one department chair, a professor, can chair only one department. So you only have one professor in one department. And only one department can have one department chair or professor. This means that the entities professor and department have a one-to-one relationship. So as mentioned before, each professor works for the college, and therefore the professor identification is through the employee ID. The one-to-one professor chairs department relationship is implemented by having an employee ID as a foreign key in the department table. As you can see the arrow there that's pointing across. Also, the professor table contains department ID foreign key to be implemented by the one-to-many relationship in the department table. Okay, so that's the second arrow there. You can see that the department ID is referenced in that professor table. A many-to-many relationship is not supported directly in a relational environment, as we mentioned before. However, a many-to-many relationship can be implemented by creating a new entity. Problems that are caused by many-to-many relationship can be avoided by creating a composite key. This is called creating a bridging table. Consider a typical college environment in which there's a student which takes classes, and each class can contain many students. Unique. So each class can have many students, and each student can take many classes. There can be many rows in the class table for any given row in the student table, and there can be many rows in the student table for any given row in the class table. So to examine the many-to-many relationship more closely, imagine a small college with two students who take a couple of classes. In this case, the many-to-many relationship shouldn't be implemented for two good reasons. Firstly, the table creates many redundancies, so duplications of data. For example, the student ID values would occur many times in the student table. And secondly, given the structure of the content and the contents of the two tables, the relational operation becomes very complex and are likely to lead to system inefficiencies and errors. So it's going to affect our data integrity. The problems that are caused by a many-to-many relationship can be avoided by creating a composite key in the new table. So the composite key is the two foreign keys from our other tables, which are linked together to create that unique identifier. So finally, we can see this enrollment table is created as a bridging table to eliminate that many-to-many relationship, and it creates a one-to-many relationship between the existing tables which were there before. So you can see the composite key which we created and we discussed before, and we're using the two foreign keys from the other tables to create that link. You can also see that the students and the class tables now contain one row per entity, and the enroll table contains multiple occurrences of the foreign key value, which is fine because it's not unique, but those controlled redundancies are incapable of producing abnormal or any anomalies as long as the referential integrity is enforced. In the many-to-many relationship below, you can see how we can create a new bridging table to relieve that many-to-many relationship and create a one-to-many relationship. In this final ERD diagram, you can see how all of our tables are related to each other. We can see how the student registers to the enrolment, and there's a one-to-many relationship there. We can see that the enrolment has one class within it. We can see that there are many classes for any given course. So we can see how over the progress of this presentation we've been able to model this diagram. And that's all. Thanks very much for watching.